Okay, so I'm just going to shrink this so I can see the code, and then I can see a whiteboard when I bring whiteboard up, wherever the whiteboard's gone. When it loads up, oh, everything gets slower and slower. Is it doing anything? Right, okay, so I'm just going to put ACC num1 and num2. Right, so I'm going to start with input. Right, we've got to remember what input does. What does it do? What does input do? Takes an input and puts it where? Right, okay, so we were told in part B of this question down here, it said what happens when we input 4 and 9. So we've been given the data to use. So we're going to do the first instruction, input. So we input a 4, it goes into the accumulator. So what we do is we just write down 4 in the accumulator column. Right, the next instruction says store num A. So what does that do? It transfers the accumulator to num A, doesn't it? Doesn't change the accumulator. That's the important bit. But so, oh, I've called num1. God, num B. So in num A, we end up with 4. Right, next instruction is input. So we're going to input a 9. Where does that go? Accumulator. We just write that as the next thing down. If we stop at any point, we can look at the bottom of each one of these columns and see what the current contents is. So I can see I've got 9 in the accumulator, 4 in num A, and an undefined value in num B. Don't know what's in there. Don't care what's in there. Right. So the next instruction then says store num B. Oh, okay. So we're going to put the 9 in num B. Right. Then we get a subtract. So subtract does what? Right. So whatever's in the accumulator, we subtract the value given. So the value is given as num A. So that's the location of the data. So we subtract 4. So we look up the bottom. We say, right, okay, so we got 9 minus 4. So what ends up in the accumulator? 5. Okay. So that was that instruction. Now, the next instruction says branch plus not A. So what does that do? Yeah. So we're going to follow that branch instruction, aren't we? Right. So we're going to go to not A, which says load the value num A to the accumulator. So the accumulator ends up with 4 in it, because I've looked that up. And then we output it. So I'm going to put down here, I'm just going to say out 4. Right, so that's what the program does. What did it say at the start the program's purpose was? It is supposed to take in 2 numbers and output the higher. Well, it hasn't done that, has it? At all. Okay, so it's actually outputted the smaller number. Yeah? Right. How can we fix this program? What should it have done? Well, should we try that? Switch it round for load num B instead of load num A. So if we was to replace that line there, where it says LDA num A, because they've said not A and then said load A, haven't they? So it's like someone's made just a simple mistake. So if that actually was, instead of that, we put not A should be LDA num B, then it would have outputted 9, wouldn't it? Because it would have loaded that to the accumulator and then would have outputted that. Yep. Is the other line correct though? So if it's not positive, it says load num B. Does that need to change? What does it need to change to? Yeah, that needs to be output in the A, doesn't it? So that line, so the line that was LDA num B, that needs to be rewritten as LDA num A. Okay. Notice what they've done with this program. It says jump to quit, which is where the output. So they only do the output code once. Okay. Now that was obviously, is everyone happy with that? This is Little Man Computer. You're going to get questions where they say trace this program, and then maybe people was asking me yesterday saying, right, so what we're going to be expected to do. This is the sort of thing they're going to expect you to be able to do, to be able to like say, right, I can. It doesn't work properly. Let me fix it. In the same way at GCSE, you might have been given a little bit of a task where they got the logic wrong in an if, and they said fix it, where they did a less than when it should have been a greater than or something. Okay, so similar thing. Right. Have a look at. Oh, I'm not in my team now. Oh, this is going to kick. If it stops sharing the screen, let me know because I'm just going back to Teams a different way. Right, so. Oh, what stupid is that? Oh, Teams is rubbish. You are total rubbish. Right, let's have a look at question 1. Zoom that in. Right, have a go. The other bits are just CPU questions. Right, well, I'm not interested in that bit. It's part C that I'm interested in. Right, so I have a go at writing a Little Man Computer program that does that task and then dry run it. So run it. Do a trace table in the same manner to verify that your program works. Paused it. OBS interface is confusing. Right, go on. Imp, yeah. Yeah. Oh, I haven't put a label there, have I? Did you have that as start? Oh, is it not? Right, so I had to start at on a label at the start, yeah? Right, so what was after BRZ end? Yeah. Oh, yeah, because yeah. Right. At first glance, can anyone see any problems with this? Apart from them. Yeah. Do we need to store the input? Right. That is a good question though. And right, so do we need to store the input? The task was input a number. It does get stored. It gets stored in the accumulator. It's not stored in RAM, fair enough, but it's actually stored. The register, the accumulator, is storage. It's just CPU storage. You only store things if you need to. If you just need it as a throwaway, and in this one it just was keep asking them to input something until they get the right number, then we don't need to store it, do we? We don't care that they've entered 3 if we check that they entered 3. We know they entered 3. We actually don't need it logically, do we? Say, right, yeah, I'm checking to see if they entered 3. If they got through the checking procedure, they must have entered 3. I don't need to record that to say they did. So try and think, and it doesn't matter if you have stored it, that's not the wrong solution. If you've got a store statement, that's not a wrong solution. It's just not as efficient as it could have been. That's all. It does not matter. Okay, so yeah, this has got the main components that you'll always be expected to demonstrate. We want to do a mathematical operation with a fixed value, so we can't do that in Little Man Computer, so we have to do this thing where we mess about and we create a variable that holds that value. Once you get your head around that, Little Man Computer is not too bad, but it is quite a weird moment where you have to say, hang on, what I can't just subtract 3, I've got to look it up and store a 3 there. Yeah, that is Little Man Computer. So that was quite a good solution. Okay, I'm going to trace it to make sure it works. So I'm going to do accumulator. I haven't got anything else that I need to keep track of. It's quite a simple program. So I'm going to try it with the number 4. So I'm going to input 4. I'm going to subtract 3, which will give me a 1. So that branch Z, no, it's not 0, so I'm not going to follow that. So I drop down and it execute the branch always, which is not, there's no condition, we just do it. It's just saying, hey, go back to this location. So I do another input. So now I'm going to input 3. I'm going to subtract 3, which gives me a 0 in the accumulator. I then hit this line, BRZ, go to end, that just says halt. One thing they may ask you in the exam question, and I would say, show the contents of the accumulator over time. And we've got it there. You can see that we had a 4. When we subtracted 3, it left 1. Then we inputted a 3. When we subtracted, it left 0. So I've got that sequence. Okay. Right. Can we look at question 4? I've had another question on there. Question 4. Right. So I don't want you to put this in my computer. I want you to trace it through. It doesn't tell you what this program does. Okay. So if I just maximize that and zoom a little bit. Right. So we've got a program. It's keeping track of a counter. You don't need to keep track of 1 and 0. Okay, because you can just read them each time. But you do need to keep track of count and the accumulator. So not a lot to keep track of. Okay, just take it carefully. Don't interpret. That is my number 1 bit of advice when you're doing tracing. Don't interpret anything. Just do what it says. And then you'll have to look back at how the numbers changed to see what the program was doing. Okay, so just try and dry run that with just keeping track of whatever count is. So I always tend to start with the accumulator and then I put my other values in there and count. So count starts at 3, so make sure you preload with a 3. Okay, and then start with the LDA1. You might need, because you're going to do out a few times, you might want to key an output column. And every time you out, so that you can then look back to see what the output was. So yeah, you might want to keep track of the output there. Okay, off you go with that. Right, so I'm going to do LDA1, so that's looking that up. They could have been really mean and put a 0 in there and a 1 in a 0 one, just to confuse the hell out of you. But they didn't. Right, so that loads that and then outputs it. So we output a 1. Then it loads a 0, outputs a 0. Then it loads count, subtracts 1 from count, so the accumulator goes to 2. And then we store it. So this little block where you have load a value, subtract a value, store a value. If you was writing this in pseudocode, you would write it maybe like this. You might say count. Well, we could write it in a few different ways if you want to follow Spider-Man. We could write count plus equals 1, or we could do count plus plus. So can you see that when we're writing in a high-level language? Oh, All right, I'll change it to a minus then. Same thing. Right, so when we're writing in a high-level language, we're more focusing on the intent of what we want. We don't worry about how does that physically is that carried out on the CPU. But when we're doing little man computer, we have to worry about those sort of things. So it's all right, if I want to subtract one from a value, I need to get it, do the mathematics, and then save it again. So something that looks to us like it's just a one thing, count minus minus, it's actually 3 steps in little man computer. Okay. What's interesting on most CPUs is you have instructions like this, where you have dec, and you might actually be able to say dec count, and it automatically goes and does that in one instruction for you. Okay. Right. So yeah, we that's the sort of thing that you might have to do if you're doing a tally or something like that. You'll be loading, making an adjustment, saving it again before you move on. Right. So we do that bit. Then it said go back to the start. Oh, it had a branch plus. Yeah, it is plus. So we go back to start. So we load in a 1. I've got that's all in my way now, isn't it? Oh, I'll just carry it on. Right, 1, and we output it. Then we load a 0. So every time around this loop, it's doing a 1, then a 0, isn't it? Okay. Then we load the value of count. Now, what I didn't do on the last bit because I got distracted, I didn't write count back, so I'll just do that there. So we load that up, subtract 1, write it back. Is it positive? Yes, it is. And go back to the start. So we will do another 1, output it, a 0, output it. Then we're going to load up count, which is now 1, subtract 1, leaves us 0, write that back, and then we say branch positive. Be careful, this is like them testing you in an exam and saying less than or less than and greater than. Branch positive, 0 is counted as positive. Okay, so we are going to follow the branch. So we go back and do it all again one more time. Then we load up the 0, subtract the 1, so count ends up with -1 in it. Then we say, whoa, hang on a minute, it's not positive, do not follow this branch. Halt is the next instruction, so we stop. So actually the mark scheme answer, I'll show you the mark scheme answer because it's insane. You should have had 4 sets of ones and noughts if you followed the loop counting properly. The mark scheme answer, let's grab it. Right, there were 3 marks for this question. This was the thing. Answer contains at least one followed by a 0, 1 mark. So if you totally didn't know what you were doing, you just did the first 4 steps, you got 1 mark. So it's fair. Answer contains at least 3 1-0s. You got another mark. So if you didn't count the loop properly, you could get 2 of the 3 marks. And then if you got it exactly right, you got the 3rd mark. The mark schemes are weird, and you obviously you're going to see all the mark schemes for everything. But look at that bit where it says allow answers that are vertical or horizontal. What? That's just I don't know why they've done that. It's like you might have just written output horizontally, mightn't you? What does that matter? Yeah, you could have done. So yeah, it's a bit mad, but it shows you. Whenever I see things like that, it shows you the sort of thinking that's going on in the person marking and how directed they have to be with these mark schemes. Did anyone have any problems with that? So tracing is just about being methodical. When we do high-level language programs and trace them, so we get given an algorithm, it's the same process. All right, so you're never going to be doing something where you're going, oh my God, this is so complicated. You're going to be going, well, I'm doing ifs, I'm going to be in loops. There ain't much else going to be going on. Just a matter of keeping track of things. Right, let's have a look at question 3. This was the horrible question. Right. What really annoyed me about this is that this should have been an 8-mark question, this first bit. But they gave it a throwaway 1 mark for each. The amount of thought that goes into this is diabolical for 1 mark. It's like writing an essay question. Okay, right, so we've got Little Man Computer. We know it's got one addressing mode. Direct addressing, where the operand is and address where the data is. The other addressing modes we have got are immediate addressing. That's where the value is the data. So immediate addressing will be like what we want to do in Little Man Computer, like subtract 1. The other ones are indexed addressing, and that's the one where you have a base value and an offset. And the final one is indirect addressing, where the operand is an address at that location is an address where the data is. Now what they want you to do, they've made up 2 addressing modes. So the instruction at memory location 0 says LDA and 7. So and's marking the addressing mode, but they don't tell you what that is. Okay. Address 1, we've got add #4. So again, that's an addressing mode that says how to interpret the 4. Now they've said the output is 17 from this program. State the addressing mode in the instruction at address 0 and the instruction at address 1. So you've got to try and trace this. So basically you've got to do a trace, and you've got to make an assumption that the 7 and the 4 are either indexed addressing, indirect addressing, or they're a constant. They're the actual data, immediate. So can you, and the thing is, you've got a few combinations here, haven't you? So there's like, what, six or 7 combinations that it could be, which one's which. So you've got to trace it. So have a guess at what you think and hash will be. Assume that they're that and try and trace this out. Okay, I'll give you a few minutes to try and have a go at that, and then I'll show you my process for this. But I want you to try and come up. Right, so I'm going to rule out index addressing because index requires a base and offset value, however we supply that. And neither of these instructions is using 2 values. So there must either be indirect or immediate addressing. So I'm going to make an assumption that ampersand is indirect and hash is immediate. Okay. The reason I'm doing that is because in a lot of assemblers, hash is immediate addressing mode. Okay, so I'm just going off that. I don't know. All I'm doing here is doing output and a bit of arithmetic. So I've only got to keep track of the accumulator and what gets outputted. Now I'm told that the answer should be 17. So I'm just going to put that in a bracket at the top so I can see. Right, so it says load and 7. Now I've said that's indirect. So that's an address of an address. So I'm going to look at 7 and it's got 15 in there. So actually 15 is the address of the data. What can you tell me about the memory address 15? It's not there. We don't know. So actually that must be wrong then. So I'm not going to make an assumption. So I'm going to say, well, that didn't work. So 15 and I still haven't got anywhere. So that can't be right, but I need to check the other one. So I'm now going to say, right, and is immediate. So that failed. And hash is indirect. Assuming I've not caught that completely. Right, okay, so immediate. So that means LDA and 7 means load the value 7. So the accumulator ends up with 7. Then we're going to add. indirect 4. So I'm going to go to address 4 and see what's there. Address 4 is 6. That is the address of the data. So that, in reality, what would happen here, inside a real CPU, I've decoded this instruction and gone, okay, it's indirect addressing. I would put the 4 in the memory address register. I would then initiate a fetch, and at the MDR would arrive 6. I know that that's the address I want, so that immediately goes into the memory address register, and then we do another read. So we're reading from location 6, which has got the data 10. So that arrives at the CPU, and we add it to the accumulator. That gives us the answer. So the answer was, and percent was immediate, hash was indirect. Okay. That was quite a lot of deep thought, even just to actually understand what the hell the question wanted at the start, for 2 marks. I don't think that was fair at all. I would have given 4 marks for that, because it's worthy of 4 or 5 minutes of exam time. In the actual exam, you get an hour and 40 minutes for each paper. So quite a substantial chunk of time. 2.5 hours actually. It's 140 marks for each paper, 2.5 hours for each paper. That's good. More time is better. It gives you time to review things. It gives you time to have a quick read of the paper, get your head settled. You know, that is not a major problem. Right, okay, what I want you to do, I'm going to stop recording.